Today we are learning about regression in SPSS. And the first file I have opened here is the regression file. And you can find that if we go back to the week 8 assignments. So assignments, week 8 assignments, and then the first folder is the PDF tutorial and files. So this is the packet that I'm going to walk along with you. And then these are the files that we use. So right now I'm using the regression file. And in this file, we have a few variables here. The first one is a salesperson, years of experience this year, and then years experience 2 means the next year. So that's just increased by 1. The years of education and last year's sales. So when I go back to the data value view, you can see the person, how many current years of experience they have, how many they will have as of next year, their years of education, and the last sale that they had. So what we're going to do is we're going to start with just creating a scatter plot and then go into some linear regression. I will show you how we can also see other forms of regression. But for now, we're going to start with linear. So we are going to go to graphs. And I'm going to go to, let's see if I hit scatter dot. Yep, scatter dot. Here we go. I want just a simple scatter. So that's the one that's already selected. I'm going to click define. So for the Y variable, I want to be last year's sales. I'm going to see if there is a relationship between the current years of experience and how much they sold. So does someone with more experience sell more? I'm going to then click OK. And you will see we have a graph right here. So this, again, is years of experience graphed with last year's sales. And it does look that there is a linear relationship here. So that the more years of experience, the more you sold. So if we want to be able to actually get the linear equation, the linear regression information, we're going to go through the analyze. We are going to go to regression. And because this does look linear, I am going to use linear here. You could see all the other options that were there. So I want to see the same variables. Dependent was sales based on last year's years of experience. So I put sales as my dependent and years of experience as my independent, because years of experience was on my X, sales was on my Y. Okay, I'm just going to click OK. I don't need to do anything else here. And you're going to get a whole bunch of different stuff here. So first you'll see here is your R, which is your absolute value. Now, SPSS does the absolute value of your correlation coefficient. So that is something to be cautious about here, because in StatCrunch, those of you that have used StatCrunch, R comes out as a positive or a negative and then tells you the direction of the relationship as well as the strength of the relationship. So R values that are close to positive or -1 are a very, very strong relationship. And then the closer you get to 0, the weaker you are. General frame of reference that I kind of follow is anything from like 0.8 to 1 is pretty strong, is strong or really strong. Anything from in that like 0.5 to 0.7 is kind of like a moderate relationship. When you get into those like 0.3s, 0.4s, you have a kind of a weak relationship, and anything really close to 0, of course, then is not a linear relationship. And depending on the resource you use, those values can kind of flux. Again, it's just kind of a standard that I kind of follow, that I found to kind of be acceptable. So just know that you always want to look back at your relationship here. So this is, of course, a positive relationship. If the values were going down, R, because it is calculated as the absolute value, is still going to show as a positive here, but you need to know that it is a negative relationship. R squared is the coefficient of determination. That is the proportion of variation that is explained by the model. So in this case, about 92% of any variation is explained in our model. Now, we're not doing ANOVA, so you can kind of skip past this. This right here is going to give us our coefficients. So this here is the constant and then the slope. So when I look at this, I'm going to insert a little text box here so you guys can see what I'm doing. Oops, I want to do it underneath this. So insert new text. All right, so what this is showing me here, y equals, the constant is the constant, so 440.987 plus, and then this is the slope, 1954.658 times x. So that is the linear regression equation for the relationship we have graphed. So what I'm going to do is I'm going to see if I take my equation, can I predict what next year's sales will be for each individual? So remember that our linear regression was based off of current years of experience. So what I want to do is I want to predict how much you're going to sell the next year based on your next year's experience. So we're going to use this one here. So what we're going to do is transform, and we're going to compute a new variable. So this is going to be, I'm going to call it new sale simple, because we're just doing our basic linear regression. So what I'm going to do is I'm going to take, that was 440.987 plus, now I'm going to take the next year's experience and times that by the slope, 1954.658. Oops, 54, not 57.658. Okay. What this is going to do is it is going to create me a new column predicting here my next year's sales. So I can go back here if I want now, and I can change this into a dollar amount. And I can set it to no decimal places, just so that it matches what my other data looked like. And now you can compare between the two. So it looks like Achilles, according to the formula, is actually not going to sell as much. But Iowa is going to sell about 3,000 more. Agamemnon, I don't know how you're going to say that, is going to sell about 3,000 more. Anna's going to sell about 6,000 more. So you can kind of see, comparing, we at least could make a prediction of where they're going to be. Now, we always know that in reality, there's always going to be slight variations from that. But for now, this is a good prediction. What if, instead of just basing it on years of experience, I run a multiple variable regression, basing it on years of experience and education? Well, we can do that here. So I'm going to analyze regression. It's still a linear relationship. We know that. But what I want to do is I want to add in here to my dependent, I also want to add in my years of education. So I want to now change my linear equation to represent sales is now based on both experience and education. So it's going to give me the same things here. It's going to give me my linear regression. And if you look here, 0.988 compared to 0.958, this is actually a stronger prediction tool because the R value is even closer to 1. So using a multiple regression here is actually a better predictor of what sales are going to be. Now, we have multiple variables here, though, that come out into my coefficient table. So how do we write this as an equation? Not text file. Oops, sorry. We want just a new text. Okay, so y is going to equal my constant, negative 8,510.838 plus 1,874.5 is going to be times by my year's experience. And add 609.391 is going to be times by the year's education. And you could also use variables for this. So negative 8510.838 plus 1874.5. You could make that X. 9.391. You could make that Z. So now we're going to run the same thing, create a new variable based on this equation. So transform, make a new variable. So I need to clear this out. This is new cell multi now, so because I'm using two variables. So negative 8,000, make sure I have my variables here. 500, oops, over here. Negative 8,510.838 plus 1874.5 is times by years of experience 2 plus 609.391 times by years of education. Okay, so I'm going to run that. And then here's my new predictor. So from 6,590 to 8,000, 4,230 to 65. So I think this one, if I remember correctly, I'm actually going to get rid of the decimals here. Make it a dollar amount and no decimals, just to make it easier to read. I believe we don't have any more of that like going down prediction, if I remember correctly. I know there's a lot of data in here, but either way, this one is a much more accurate tool to predict the next year's sales than just using a simple linear regression. Now I'm going to open the growth data set. I used to talk about the bonus one. It's not so much anything we're going to be doing. So I'm going to look at the growth one because this is going to help you when you create your problem and get your data to determine the type of relationship that you have. So what this data set has is age and weight of 19 different individuals. So what we're going to do first is make our scatter plot. So graph, scatter, simple scatter. Age is the X, weight is the Y. All right, so when I look at this here, you may say there's kind of a linear relationship, but you may also see there's a little more of kind of a curved relationship here. So what we're going to do is I'm going to show you how from the scatter plot we can add an equation or a line and see which one's kind of the best. So I am going to double click this guy here. And this is the one I want here. So add a fit line at total. This is the one I want to do. Now, you can see that default selection is linear. And what it's doing right here, so here's linear. I have the equation. And I will try to go back and show you how we can actually see all of the values here, because this is E, that means it's timesing by 10 to a power, so we can get the correct value. You can see here, here's the R squared value. So pretty good linear relationship if R squared is 0.973. I could look if a quadratic is any better. And if I click apply, the R squared is the same, 973. Okay, but what I think is it's actually a little more cubic. So let's apply that. And now my R squared is 0.996. So you can see and play with it right here to see which one is the best. So is it linear? Is it quadratic? Is it cubic? Is it this one here, lowest? And there are other ways to pick other options, and we can discuss that in a little bit here. But for this example, the best model is actually a cubic relationship. So I'm going to close that there. All right, so what I'm going to do then is go back to analyze regression. Oops, wrong. Analyze regression curve estimate. Okay, so I have weight was dependent on age, and we found that the cubic was the best. So you do have the option here if you're trying the curve estimation. There's a few other ones. Compound. Is it a growth curve? Is it a logarithmic curve? Is it exponential, power? So there's other options this way versus just using the fit at total, that line inside of the graph, but that at least gives us a good starting point. So curve estimation, we want to see the cubic. I'm going to click OK. And it is going to be that same line that is there. So it does match. So the question then becomes, how do I write this equation? Because when I look up here, you can't see all of the pieces. So they're actually all in this one here, model summary and parameter estimates. So let me add my text here. So y equals, I'm going to go in order. So constant, x squared x cubed. So 0.052 plus, nope, that's minus 0.17x plus 0.010x squared minus 0.001x cubed. So this is how I get my equation here if it's a cubic. If it was a squared, you'd have constant, your x, and then your x squared. So one of the things that you are going to do is you are going to pose a question to 15 different individuals. It's got to be numeric, 2 numeric values. So the example I gave was your age and your shoe size. And what you're going to do is you're going to graph your data, and then you get to kind of play with this fit at total to determine, is it linear, or is there a better relationship that I could use that's not linear? Is it quadratic? Is it cubic? Or do I want to try one of the other ones? Oops. Didn't mean to close that there. One of the other ones that when I go here to regression and curve estimation, do I want to see a compound model, a growth model, an exponential logarithmic? So there's all these other options here. Most of what we're going to work with here is either linear, kind of curved kind of examples. That's the basics of where we're going to start. But SPSS does go a whole lot more in depth. I know if you are a grad student, you have to take math modeling. So you learn how to do a whole bunch of this kind of stuff in Excel. So just know that SPSS is a similar tool. You can use it just like you use Excel to find the best line of fit. Okay, so this week you have under your assignments for week 8, you are looking at cricket and temperature data, as well as laptop depreciation data. And then you are going to create your own data set by asking 15 people for 2 pieces of information, and then determining what the best model is for your relationship of your data that you have. Just remember, there's some questions in here like use the prediction to estimate. So if you have an equation, I may be asking you to plug in for the x value. I may be asking you to plug in for the y value. So just remember some of those basic algebra skills as far as if you have your equation, plugging in one, solve for the other. And that is what we have this week. I've emailed all of you a current progress report. Highlighted yellows are things that are missing. Please, please, please get in your work as soon as possible. If you have any questions, you can email me